So in example 1 and 2, we'll be doing the following. We'll be solving the inequalities. We're going to graph them. And then we're going to decide if they are an AND inequality. So remember, that's when the arrows collide into one another. Or if they are an OR inequality, where the arrows go opposite directions. So we cannot determine that until we have graphed it at the very end. So when you guys solve inequalities, you solve them exactly like you would with an equal sign. Now the only thing you have to look out for, if you ever multiply or divide a negative number on both sides of the inequality will flip. So that's something that you have to remember when you solve inequalities. But otherwise, they're the same as an equation. So let's get going. So I like to keep my work organized, so I'm going to put one inequality on one side of my line and the other inequality on the other. And I'm going to put them in different colors just to make it more easy for you guys to see. So that's on one side and the other will be on the other side. So I'm going to start on my left hand side. So all we're going to do is try to get x by itself like we would in any equation. So just pretend like that's an equal sign when you solve. So the first thing we're going to do to get x by itself, we always do the adding and subtracting first when we're getting x by itself. So I'm going to move my positive 18 to the other side, which the way we do that is by subtracting, because subtracting is the opposite of addition. So this will cancel. And I'm going to subtract 18 from my 9. 9 minus 18 will give me a negative 9. So now what I'm currently left with is 3x is less than negative 9. Alright, to get x on one side by itself, the 3 is secretly multiplying to my x, and the way that we move that to the other side is by dividing, because division is the opposite of multiplication. So on this side, my final answer will be x, this will cancel, so you're left with 1x, or just x, is less than negative 9 divided by 3 is negative 3. So that is one of my inequalities that I'll be graphing later on. So I'm going to kind of ignore that for now, and now we're going to shift gears onto this side of the problem. So on this side, again, we do our addition and subtraction first when we solve an equation or inequality. So I'm going to move my 18 to the other side, which the way we move that bad boy over, since it's a positive 18, I'm going to subtract that thing to the other side. On this side it cancels. Negative 9 minus 18 more will give me a negative 27. So now I'm left with 3x is greater than negative 27. And the way we move the 3 to the other side, since I'm multiplying, the opposite of multiplication is division. So 3 divided by 3 turns to 1. So this is like 1x, or just x, is greater than negative 27 divided by 3 will give me a negative 9. So from here, once we've solved each inequality separately, we're going to be putting these numbers on our inequality. So for now, or we're going to put these numbers in the inequality on our number line. Sorry. So I'm going to be focusing on these numbers right now. Those are going to be the only numbers that you put on your number line. Okay, you don't have to put all the numbers in between negative 3 and negative 9. It's a waste of time. So these are the only numbers I'm going to be putting on this number line. And you always put the smallest number on the left-hand side, which negative 9 is smaller than negative 3. So I'm going to put negative 9 on the left-hand side. I'm going to put negative 3 on the right-hand side. Alright, and since I'm just going to do this already before I forget, since these are not equal to, that means my bubbles on each of these numbers are going to be open bubbles. So eventually when I graph this, my final answer will have open bubbles. Alright, now we have to determine if it is an AND or if it is an OR. So let's see what happens. So I'm going to be graphing my very first inequality first, this one right here. I'm going to graph them separately before I put it on my number line. So we're starting at negative 3. I'm going to do it above the number line so you can kind of see a little bit better. Alright, and then this one this is where x is all the values that are less than negative 3. So if you think about it, the numbers in between here are like -4, -5, -6, etc. So, and the numbers on this side are like -2, -1, 0. So I want numbers that are smaller than -3. So the numbers that are smaller than -3 are headed this way. So my arrow is going to point this way, like so. So that is our first inequality. Now my next inequality, these are all the values that are greater than 9. So the numbers that are greater than 9, so on this side we have some numbers over here listed. So on the other side of 9 we have things like -10, -11, -12, etc. So the numbers that are larger than -9 would be these over here. -6, -5, and -4 are larger than -9. So we're going to start at -9 and we're going to head this direction because these are all the values that are greater than 9. Now a shortcut to help you out, this only works if x is on the left hand side. If you notice, my arrows kind of point in the same way that the inequality went. So like here, see how the green arrow is pointing to the left, and see how this arrow goes to the left? Okay, and also on this side, see how the blue arrow points to the right and my blue arrow heads to the right. So that's kind of a shortcut, but you can only do that if x is on the left hand side. If this were written like this, you cannot do it anymore because now my arrow is not pointing the same way that this one is. So x has to be on the left hand side if you use that trick. Okay, so now we need to determine, is this an and or an or scenario? Well, if you notice, this car was heading this way and this car was heading this way, and unfortunately the cars collide. They get into a horrific accident, and where they collide is in between -9 and -3. So I'm going to shade where they collide. So they kind of collide in this area right here. So that's where I shade. So since my two values collide, this is going to be an and inequality. Okay, so this is an and. Alright, and my final answer, remember for the and, you put the number that's on the left hand side on the left, the number that's on the right hand side on the right. You put your x in the middle, and since these are not equal to, we're going to use those same symbols. So these are all the values that are greater than -9, and these are all the values that are less than -3. And that's always how your and inequality should look. And that would be my final answer. Wasn't that exciting? So now we are going to do the same thing except with a different scenario. So on this one, same idea as before. Okay, we're going to start by writing each of these on each side of my line to keep things organized. And like before, I'm going to do them in different colors to help you guys see the problem a little better. So we have x plus 8 is greater than or equal to 6, and x plus 8 is less than or equal to -6. Alright guys, I'm excited. Why don't we dive in? So like last time, we're going to solve each of these problems separately, and we get x on one side by itself. So on this one, to get x by itself, this is a little faster. We're going to subtract 8 on both sides because the opposite of positive 8 is a -8. So these will cancel and turn to 0. Sorry about that. Didn't mean to write that. So this side it cancels and turns to 0. This side, 6 minus 8, will give me a -2. So now my final answer on this side is that x is greater than or equal to -2. Now that x is by itself, I can move on to the other side of my equation. So again, we're trying to get x by itself, so the way that we move 8 to the other side is to subtract 8 on both sides. Subtract that bad boy onto both sides of my equation. 8 minus 8 is 0, and -6 minus 8 more will give me a -14. So on this side, we have x is less than or equal to -14. Alright, so now that we got x by itself on both sides, we're going to be moving down to our number line. And we're going to determine if this thing is an and or if it's an or. So, remember you put your smallest number on the left hand side, which my smallest number is -14. Yep. And my larger number is -2. So I'm going to put it on this side. So if it helps you to write in a few numbers, you can do that. Some people that does help them. So things that go on this side of my number line are things like -1, 0. Things in between -14 and -2 are things like -3, -4, -5. Alright, and things that are smaller than -14 are things like -15, -16, -17. So that might help you just when you're trying to determine where to write your arrows, but you don't have to do that. So, let's continue on. So, for my first inequality, okay, first of all, since these are equal to, I'm already going to go ahead and do closed bubbles. Because remember with our piecewise functions, if it's equal to, we shade in our bubbles. Alright, so on the first one, we have x is greater than or equal to -2. So I'm going to start here. Alright, the values where x is greater than or equal to -2 are on this side. Things like -1 and 0 are greater than -2. So they're going to head this way. Sorry guys, the sun is interfering with my lovely video. Alright, and then on this one, let's see what happens. Remember, it's an and if they collide, it's an or if they go separate ways. So for this one, where x is less than or equal to 14, I'm going to start at 14, and the values that are less than -14 are on this side of my number line. They're things like -15 and -16. So they're going to head this way. Holy hot dog, the cars went separate ways and they did not collide. It's been a great day. So, since they did not collide, this is going to be an or. And remember, with ors, our arrows go separate ways. So on this one, I'm just going to shade in where the arrows go, because they go their separate ways. I like to overemphasize my arrows, so I kind of shade in my arrows so you can see it a little better. Alright, so we know that this is an and, so my final answer we know this is an or because the arrows go different ways. So for my final answer, ors are a little easier to write. You just basically write both of these with an or in between. Okay, it doesn't really matter which one you pick first, so this is an or. Alright, and I'm going to say its x is less than or equal to -14, or x is going to be greater than or equal to 2. Sorry, -2. And that would be my final answer. It's been a blast, you guys. So this one was an or, and this one was an and.